Hello class, today we're talking about quadratic maximization and minimization. So we're getting into quadratic functions just for a few lessons here. And a quadratic function is any function that's to the second power, such as f of x equals x squared, or such as f of x equals negative x squared. You may also see them written like this, where it's ax squared plus bx plus c, something like that. Anyway, so a quadratic function is a function that's a second degree polynomial, right? Degree is the highest number, or the highest exponent, right? And the shape of a quadratic is a parabola. It's kind of like a U-shaped, if you notice. And we have two specific kinds. We have a positive and a negative. Now, the only difference is that a positive will have just a positive out front of the x squared, and a negative will have a negative in front of the x squared. And I mean specifically the x squared term. Not the b or not the c, but right in front of the x squared. So it'd be the very first thing you see, either a positive or negative. And that determines which way these parabolas open up. If it's positive, they open up, and if they're negative, they open down, kind of like a frown, if you'll see, right? Well, parabolas have what we call a vertex, and a vertex is the point at which the parabola changes direction, and it's either, depending whether it's positive or negative, it's either going to be the lowest point of the function or the absolute highest point of the function. Now, why is that important to us? Well, we're talking about maximization and minimization here. What those two terms mean, it's really big in business. You try to minimize production costs while you try to maximize profits. And many times there will be equations, such as quadratics, that accurately model the costs to produce and profits. And so there's kind of a sweet spot you want to hit. That, for instance, here, like, if this models how much it costs to make a certain amount of product, you want to make the amount right in the middle, where the vertex is, because that will give you the least amount of cost. Now, if you're talking about profit, you'll want to meet right in the middle, where it's the highest point, because you're trying to maximize your profit and minimize the cost of production. Now, where can we find the vertex? That's the question for the ages, really. Well, not really the ages, because we have the answer for it. But that's the question of the day. Where do we find the vertex? And that is from the vertex formula. Now, the vertex formula is x equals negative b over 2a. When it's in this form, a is the coefficient of the x squared term, b is the coefficient of the x term. Now that just gives us the x value of the vertex. If we wanted to find the y value of the vertex, we just plug in whatever we got back in for x and simplify. So today we're going to be talking about maximization and minimization, and we find that by using the vertex formula. So that's what we'll be using today. So let's take a look at an example here. C of x equals x squared minus 8x plus 10 represents the cost in hundreds to produce x thousand pens. How many pens should be produced to minimize the cost? What is the minimum cost? So this is a minimization problem, and this opens up, right? It's a positive, which means it's going to look like this somewhat, not exactly obvious. It's going to be placed somewhere differently on the graph. But we want to hit that sweet spot of the vertex, the very bottom, to minimize the cost. So it's less than anywhere else, the lowest part of the function, right? So in order to do so, I'm going to use the vertex formula to find out where that x value is. Or I'm going to use the vertex formula to find out how many pens, because pens are x, should be produced to minimize the cost. So let's see, my A, you don't have to write it out always, but we need to find our A and B, and I hope this would focus sometime. So I'll just focus for us. There we go. A is the coefficient of the x squared term, so in this case there's no number there, which is implied to be a 1. And B is negative 8. So if there's a negative out front, always be sure to include that negative out front, okay? And then we can just plug it into the vertex formula. So x equals negative b, negative 8, over 2a, so 2 times 1. And, well, we can simplify this. Negative times negative 8 is a positive 8. Divided by 2 times 1 is just 2. 8 divided by 2 is 4. So how many pins should be produced to minimize the cost? Well, this is in thousands, right? So this isn't 4. It represents 4,000. So our answer here is, for the first question, is 4,000 pins should be produced. So 4,000 pins should be produced to minimize the cost. Now the second question is, what is the minimum cost? Well, that would be our corresponding y value. So all we need to do with that is plug in our 4 into our function, and it'll give us the corresponding cost at 4,000 pins. How much it'll cost to produce 4,000 pins. So we can do that. I'll change colors here. C of 4, because that's what we're plugging in to our equation, equals 4 squared, this is x squared, minus 8x, so minus 8 times 4, plus 10. So again, I'm just plugging in 4 to the equation. And let's just simplify it. 4 squared is going to be 16. Negative 8 times 4 is negative 32. And then plus 10. I had a bad equation here. Let's see here. So 16 minus 32 is going to be negative 16 plus 10. You know what? I didn't make the equation as good as I thought I did. Let's say that this was 20, okay? Which would mean this is 20, and this is 20, and this is 20. So my apologies. I just changed the function because if we left it at 10, it would be a negative number, and we can't have a negative number for the cost, right? It wouldn't be a negative. It just doesn't make sense. So I apologize for that. But with this, negative 16 plus 20 is 4. So 4,000 pins should be produced, and how much does it cost? Well, the cost is in hundreds. So how many pins should be produced? Oh, and the price, the minimum cost is $400. So it costs $400 to produce 4,000 pins. So again, what do we do here? We wanted to find out how many pins should be produced, so we plugged that into the vertex formula and got our x value, and that represents how many pins should be produced in thousands, right? And then to find out what that minimum cost was, we plugged in 4 into the equation and simplified, and we got 4, which represents 400 because it's in hundreds. So the minimum cost is $400. Okay. Let's move on to a maximization problem, and it's the exact same thing. It's just instead of having a positive parabola, we'll have a negative parabola. But we're still finding the vertex. It's the exact same thing what we're doing. We're using the vertex formula to find out when it's at its peak, and then after that we plug in whatever value we got in order to find what the profit is. So P of x equals negative 2x squared plus 12x plus 20 represents the profit made in hundreds by selling x thousand cups. How many cups should be sold to maximize profit? And what is the profit? So again, I'll just rewrite it for us. Our vertex formula is this. So we need to find our a and b values. So a is going to be negative 2. It's the coefficient of the x squared term. And b is the coefficient of the x term. So that's 12. So plugging it in, we get negative 12 over 2 times negative 2, which if we continue, that's negative 12 over negative 4, which is positive 3. Remember, negative times a negative gives us a positive. So, how many cups should be sold to maximize profit? Well, this is profit made, this is cups and thousands. So this is 3, but it's not 3, it's going to be 3,000. So 3,000 cups should be sold. And then we want to know, what is the profit? Well, that we just plug in 3 into our equation and solve, or just and simplify, right? So I'll do that in a different color here. We have P of 3 equals negative 2 times 3 squared plus 12 times 3 plus 20. And simplifying, we want to do exponents before we multiply. So negative 2 times 3 squared is 9, plus 12 times 3 is 36, plus 20. Let's see, negative 2 times 9 is negative 18, plus 36, plus 20. Negative 18 plus 36 is positive 18, plus 20 is 38. So when 3,000 cups are sold, the profit is maximized at 38, and this is in hundreds, so really $3,800 is the profit. Okay. Let's do one more just for fun, just to kind of cement this idea to us. I haven't previously wrote one down, but I might as well, or well, I'll have to. So let's just do another minimization problem. Let's see. I'll take one from the worksheet, but I'll change the values. Okay. So C of x equals x squared minus 10x plus 30 represents the cost in thousands to produce x thousand computer mice. How many mice should be produced? To minimize the cost. And what is the cost? Okay. So we're going to use the vertex formula to find the lowest point of this function, because that will be the minimum cost. We need to find the x value of where that's at. So I'll just write it again. We need to find our a and b. A in this case is 1. B in this case is negative 10. And plugging it in, we get x equals negative 10 over 2 times 1, which becomes 10 over 2, which is 5. So 5 in thousands. So 5,000 computer mice should be produced. And how much will it cost to produce those 5,000 computer mice? Well, now we plug in 5 in for x. So C of 5 is equal to 5 squared minus 10 times 5 minus, let's see, 10 times 5 plus 30. So 5 squared is 25. Negative 10 times 5 is minus 50 plus 30. Let's see. This is going to be negative 25 plus 30, and we get 5. Oh, we got 5 again. Okay. So 5,000 computer mice. The cost is also in thousands, so it's going to cost $5,000 to produce. Yeah, and that's it. So it looks like it's $1 a computer mouse, right? To produce at the cheapest point. So that's all I have for y'all today. Have a good day. Let me know if you have any questions. Bye.